Well, hello there. This is Mrs. Sharp, and you are watching some notes to start off Unit 2, which is Basics of Matter and Energy. So hopefully you're ready to take some notes on this. Feel free to pause as we're going through here so you can get down everything that you need about Learning Target 2.1, which is going to discuss states of matter. So as you can see, we're going to define chemistry and matter. We're going to describe how atoms and molecules are arranged in solids, liquids, and gases. We're going to explain what changes occur as a substance changes from one phase of matter to another, so some phase changes, and we're going to start drawing some changes at what we call the submicroscopic level. You can think of submicroscopic as if you were to shrink down teeny tiny to the size of a molecule. If you looked around you, what you would see. So submicroscopic being smaller than microscopic. So small you can't even see it with a microscope, like atoms and molecules. So let's define chemistry. We talked about this the first day of class, but let's get down a definition. Chemistry is the study of matter and how it changes. You should know this, but just as a reminder, matter is anything that has mass and volume. So in other words, it has mass and takes up space. So that's quite a broad study of anything with mass and volume. We've talked about this, but mass is a measure of the amount of matter in an object. It's a constant, so it doesn't matter where you are in the universe. The mass does not change of a substance. It does not depend on gravity. And it's measured in grams or kilograms or something like that. As far as volume goes, that's the amount of space an object takes up. It is measured in liters or meters cubed, or a derivative of one of those two things. So just some reminders there, some review. Probably know most of that already. Now let's talk about the changes part a little bit. So we've talked about matter. As far as changes goes, we have 3 types of changes we'll be studying this year. The first are physical changes, and I'm sure that's a review of what you've talked about in Science 9. These are changes in form, so something like grinding it up or tearing it in half or even boiling it, so state changes. We've got chemical changes, which are also known as chemical reactions, and that's changes in the identity of matter, and we're going to talk more about those two things later on. And then we've got nuclear changes, which are when we take matter and we actually turn it into energy. So those are the 3 main types of changes that are classified under the study of chemistry. So physical changes have very small changes in energy. So something like ripping a piece of paper in half is not really all that exciting because it has some very small changes in energy. But a nuclear change, something like a nuclear reaction, is pretty intense, and that is because it has such huge changes in energy. So physical changes have the smallest amount of change in energy, and nuclear changes have large changes in energy. So those are the changes that we study in chemistry. Let's talk about matter versus energy. Now, matter we already defined as anything with mass and volume, but energy is the ability to do work or produce heat. So those two things are not necessarily the same. So think about some things that are energy that are not matter, such as if you were to talk about air. Where would that fall? Well, air is made out of particles, so that is mass and volume, so air would go over here. Air is actually a mixture of oxygen, nitrogen, some carbon dioxide, some argon, some other stuff. How about a flame? A flame does not have mass or volume. It is simply light energy. So there's a lot of things that we could classify as one or the other, or actually having both, such as wind. Wind is made up of air molecules, so it has matter. In wind, there are air molecules with mass and volume, but it's also energy because it can do work. So it's kinetic energy of the molecules in the wind that cause windmills to move. So again, I hope that that's a little bit of review for you as well. We have 2 types of energy: kinetic energy, energy of motion, and potential energy, which is energy due to composition or position. I'm sure that you have also touched on these two topics, but just to remind you, energy of motion, example is heat. Heat energy is a form of kinetic energy because the higher the temperature goes, the more heat energy something has and the faster those molecules are moving. Potential energy might be something like bond energy. So the energy in a bond that's stored in a bond is that potential energy. Because if you break that bond, you have the ability to release some energy. So now we're getting to the law of conservation of energy, which is energy cannot be created or destroyed. So energy flows. So it's never created or destroyed, but instead it flows from one thing to another, which we'll call the system and the surroundings. And we'll talk about that more here in a second. But it flows from, or actually to, the system and the surroundings. So it can be transferred. That's what I mean by flow. So it can be released from the system, and if it's released from a system, we're calling that exothermic. Now, exo means out, and thermic means heat. So it doesn't have to be heat. It can just be any kind of energy. But if the energy goes out energy, it's exothermic. If it comes in, if it's absorbed, then we call that endothermic. Endo means in, and again, thermic means heat. So if the energy is going in heat, it's called endothermic. Now at this point, I'm going to have you stop in this video and move on to part 2. That's the next video. And I apologize, I made the next part of this video when I was not feeling really well, so my voice is kind of scratchy. But I wanted to make sure you got this first part of notes, and then I'm going to have you jump over to part 2 here to continue your notes for 2.1. Thanks!